Hey guys, let's do a quick trig review. So here I have a triangle, right? The hypotenuse I have at 32, angle of 21 degrees, and I want to find y there in red. That's the opposite side. Whenever you're looking for the opposite, so you have an angle, an opposite, and hypotenuse, I would want to use sine. So here, sine of my angle, let's actually write the equation. Sine theta equals the opposite over the hypotenuse. So this is going to be sine of 21 equals y over 32. Now to solve that around, I have 32 times sine of 21 degrees. Make sure the calculator's in degrees here, equals y. Plug this into the calculator and I come out with 11.46. Not worrying about sig figs here since all we're doing is math. Now whenever I want to solve for the adjacent side, here labeled x, I would want to use cosine. So cosine of theta equals the adjacent over the hypotenuse. Once again, I have an angle, adjacent, hypotenuse here. So plugging in cosine of 21 is x over 32. Solving around, multiply both sides by 32 because it's in the denominator there. Cosine of 21 equals x. Plug all that into the calculator and I come out with 29.87. Now if I know two sides of my triangle, here's the base, here's the height, and I'm solving for a third side. This happens to be solving for the hypotenuse. I use Pythagorean Theorem. A squared plus b squared equals c squared. So plugging in here, 30 squared plus 11.5 squared would equal c squared. The left side comes out to be 1032.25 equals c squared, which is r. So let me actually come back in here and change that to an r appropriately. R squared, so now I need to square root both sides here to get r, which comes out to be about 32. Now if I'm ever looking for an angle, I would need to know two of the sides. Here I purposefully have it set up for tangent to work out perfectly because tangent of an angle is going to equal the opposite over the adjacent. Now whenever you're looking for an angle and you know sides, this theta here, the unknown, is trapped inside of whatever that function is. This works with sine, this works with cosine, it's just with sine, it would be the opposite over the hypotenuse, and with cosine it would be the adjacent over the hypotenuse, but I just have this problem set up for tangent. So I need to, let's go ahead and let's plug everything in first. So I got tangent of the theta that I'm trying to figure out equals 11.5 over 30, and I need to get that theta out from inside. So what do I use? I use the tan inverse. If I was using sine, I'd use sine inverse. So theta is going to equal tan inverse of 11.5 over 30, which comes out to be about 21 degrees.